Hey, thanks, Jimmy, and glad to see so many people here and the support of the Kubeflow community. My name is Josh Bottom, and I'm here to give an update on the Kubeflow 1.4 release. I am a Kubeflow community product manager. I've done that volunteered in that role for the last three so years, and I'm also a VP at Aricto of developer relations. So one of the things that I'd like to do is just give a few slides on where we are with Kubeflow 1.4. And in particular, my view here is that we'd start off with just talking a little bit about the community structure and kind of why we even have releases. But when you look at the community structure, right, we have users, we have working groups, we have the folks that produce the distributions. New in 1.4 is both a handbook and a release team. The release team really works as that glue between all of these different communities, gathering requirements from users, talking to the working groups who are the code contributors, making sure the distribution teams are ready to be able to support what's needed in the field. So when I look at what the purpose is for a Kubeflow release, it is to help and improve the Kubeflow user productivity through the introduction of new functionality. And that functionality is really designed to simplify operations and streamline ML workflows. Now, we give plenty of ways for folks to contact the community. We have working group and community meetings basically every week. We also have GitHub tracking of all the issues that go into the project, and we allow and answer questions both on Slack and in email. And one of the things as a product manager that I like to see is some forms of processes being matured and alignment between all these different groups. So if we look at 1.4, we see that the release handbook, which is new from this release, was approved. This walks through, and you can use that link there to go and look at the Kubeflow release handbook of what's supposed to happen in each step of the development. We have a release team. As I mentioned before, we just had one release manager, which was a lot of work. And now we have a release team with a release manager and shadows and folks responsible for documentation. We have a schedule. And the spoiler alert is the release is due on the 27th of this month. And again, there's a Kanban board to track all that. From a working group alignment, I really liked, and hopefully you guys did too, the presentations, both of the roadmaps for KF serving and KF pipelines. This was about an hour-long presentation, went into quite some depth about what these contributors are talking about delivering. And then early in the cycle, just like this one, we also did another session with the notebooks, the training operator, CATIB, the manifest to present their roadmaps. With that, we were some folks from Intel, Malini, and Shannon from Aricto helped to update the Kubeflow roadmap. And now you'll see that that is updated and to where the most recent deliveries are at the top. So I think that's very nice. And then from a user perspective, I do believe that, working with the users to have the survey like we did in March to get feedback, but even more importantly, in the community meetings, but we extend that even further to these mini summits that we had. These are day-long virtual now summits that allow maybe 8 to 10 different presenters that are either subject matter experts or in developing the code, or end users that come and present what they're doing. So we did that, one of those with KF Serving. We also did another with AutoML and the training operators. I like that a lot, and those are all recorded, and you can go in and we'll send these links are accessible to you. If you're learning about Kubeflow, this is a great way to learn a lot of the details. So from a Kubeflow 1. Schedule, you can see the handbook has identified development, feature freeze, testing by the distributions, and then the release. We're currently in the feature freeze. We have a release candidate. Here are some of the dependencies that people often ask about: the Kubernetes that we're testing with, the Istio version 1.9.6 and the Knative version. And there'll be a tracking issue for all these dependencies that you can see how things are coming along. From a theme standpoint, again, we're trying to focus on simplifying operations and streamlining ML workflows. So the streamlining of operations really, in this case, is going to improve the software foundation, quality, and usability. And a lot of this is focused at how to improve Kubeflow itself with some reduction of redundant code. So you can think that these components, the training operator for TensorFlow, PyTorch, XGBoost, MXNet, BytePS, and LightGVM, they were all developed independently. What we've done is now made a universal training operator, which means that anytime that we want to make a change, it's all kind of done in a universal way, and we can test this easier. We can introduce new features easier. We can document it easier. So this has been a big advantage now. MPI is still outside of this, but it's still being developed and delivered in 1.4. But this universal training operator, a big delivery to simplify and improve the way that we'll, improve basically the code associated with training operators. And the same thing with the web applications, kind of the same concept for the CatTib, the Models UI, and the notebooks. In addition, we're introducing more CI/CD for faster and better builds for CatTib, the training and notebooks. And we have a marker to improve the documentation. We do get feedback from the open source community that we need to improve the documentation. We will have a doc sprint. We'll talk about this a little bit more, but it will be in the regular Kubeflow meeting on September 14th. And then you see this simplified installation with refactored Kubeflow manifest. We'll talk about that a little bit more as we go forward. Streamline ML workflows, an increased use of metadata, right? So metadata for pipeline orchestration and metadata for model monitoring. A maturation of the V2 and the V2 compatible protocols for KF serving and KF pipelines. So we're starting to see this next generation of protocols coming in and improve the operational benefits of KF serving and KF pipelines. And then a KF server user interface with model details, logs, YAML, and metrics. For those of you who are keeping the score track at our scoring at home, you do have tracking issues for each of the working groups, right, that are delivering in 1.4. You have the roadmaps posted, and you'll have what they actually delivered in change logs or release notes. And Jimmy did a very nice summary of what was delivered in KF serving recently. And I advise you to look at those and track those that progress using those various links. When we talk about installation, we often find that installing Kubeflow in enterprise Kubernetes environments requires automation. And without it, what we see is you have either an inconsistent or less reliable, less secure. It's basically inefficient from an operational standpoint. So this whole idea of moving to using GitOps, so having a Git repo, the Kubeflow manifest, and using the customized tool, which is a Kubernetes native configuration management using YAML and kubectl, allows for this way to overlay different YAML configurations, which is good for people that are building distributions, and also for even enterprises that need to do customization on top of what's delivered from the community. So we do believe this Git process provides this common installation pattern for folks that's repeatable, it's secure, it's extensible, you can customize it, and it involves and includes being able to do upgrades. So this works in a single Kubeflow application as well as for a complete Kubeflow install. And you can learn more at the GitHub for manifests, as well as from the distributions. And just to talk about the distributions briefly, is that there are, I think, about 10, 11, maybe 12 distributions now. Several organizations produce and support Kubeflow distributions. I provided a link here. They have installation patterns and versions that are determined by those distribution owners. And in this link here, you can also see the folks that are responsible for building the distributions, each of the individual ones for 1.4. We really do welcome folks being involved in the community and also contributing. So if you would like to contribute, we are having a Kubeflow doc sprint on September 14th, and this will be at the Kubeflow meeting. So this is 8 a.m. Pacific time. It will run after the existing meeting that we have, so it'll probably start about 8:30. But the goal here is that we would really like folks to, bring ways that they think we can improve and at least contribute one PR. If you do, we'll make sure that if you do a Kubeflow doc pull request, that you'll get a Kubeflow contributor t-shirt. So those are kind of coveted, and hopefully you will get that early. And along with this, if you're also looking for other places to contribute, you can look at the Training Operator Working Group Kanban board. It has things that are listed as good first issues or help wanted, or you can just install the current release candidate and open GitHub issues against that. I'm going to jump to a quick demo. What I'd like to be able to show you is, because metadata is becoming more important, I'm pushing myself to learn more about it, and hopefully you will too. I'm going to show two use cases of using metadata, one to serve a model, and second, to be able to create a Tensorboard. These are all available through MiniKF. I think you probably know MiniKF is a single node cluster, easy to spin up on AWS and on GCP. But this is of a tutorial around AutoML. I'm going to jump into that tutorial and just walk through it very quickly. For those of you that are familiar with GCP, this is the same with the AWS marketplace. You can just go into the marketplace and pull up MiniKF and just click through here. And I'm just showing how easy it basically is to provision a MiniKF in GCP. With a few clicks, I get to my provisioning screen. I give it a name. I pick a zone that's close to me. I pick a machine type. I would pick a machine type with at least 30 gigabytes of memory, probably leave the boot disk and data disk and GPU as is, and just hit deploy. In a few minutes, you'll get a login credentials and you'll be able to get to this central dashboard. I've already created this notebook here. And this notebook is of a Kaggle model, which is about predicting the price of bulldozers. And so really what we're doing here is we're going to use AutoML and feed it a data set, and it will run it through 4 different models, pick the best one, tune it, and then we'll serve that model and create a Tensorboard on it. One of the things that I'd like to highlight as we walk through this is just that we have this first install command here where we're installing a lot of packages and libraries. And one of the nice things about using a MiniKF architecture or even enterprise Kubeflow architecture from Aricto is that all these installs that you're doing of packages of libraries can be stored and are automatically stored in a persistent volume. So if you ever turn off your notebook, you don't lose all your packages and libraries. You probably have experienced that in the past, but that's just a nice highlight of some of the efficiencies for the streamlining for the data scientist. We're also doing some imports, and you can see some data loading here. There's about 20,000 lines of rows of data with about 53 different features that are being analyzed. You do some data processing, we'll extract our target variable, the sales price, we'll encode some ordinal variables, we'll unfold the dates, and then we'll split the data set into train and valid data sets. So that's all this code here. I'm just going through it quickly so you can see this. Really the heart of this model are these 2 cells right here. This cell right here is setting up basically the syntax so you can use AutoML and Kale to basically go through and do these configurations that we are talking about, right? I want to run 4 different models. I'm going to run 2 of them in parallel, and I have a tuner defined. That tuner is defined up here. I'm not going to go through all that syntax today, but I've run this before, and what you see is you'll get a pipeline that basically looks like this. Using sklearn, we're going to get some configurations. We're going to run those 4 models. We'll get the output of those models. We'll take that best configuration. We'll run that through a hyperparameter tuning, and then we'll be able to use that to do those 2 use cases that we talked about. This is the actual hyperparameter tuning that we talked about being able to deliver. This is the new UI that you probably saw in 1.3. And as you've seen before, this is the best tuned model right here. And if I click into this icon right here, I can find the actual Kubeflow pipeline that created that best tuned model. Now, what I want to be able to do is use some artifacts from this best tuned model to serve my model. And I can do that just by going into this step right here and looking at the artifacts. I go into the ML metadata, and I scroll down, and I can find in the outputs that I've got my best tuned model here, which was the random forest predictor or regressor model. And I have an artifact that I can highlight here, 83. So if I highlight that, I can bring this back into my tutorial, and you can see that now I'm at serving the best performing model. And I use my Kale, and Kale brings in some utilities. And then I use this 83 from my metadata and put it into a parameter called Kale model artifact ID. And then using these Kale serving utilities, I do this syntax here, KF server, serve utility, serve model from model MD, MLMD, and then I use this Kale model artifact ID. I've already run this before, but what's really interesting about this is now you're seeing this interplay between Kale and Rock and KF serving to serve this model in a couple of pods. And that's what all this pink code is doing. And then it brings this up as an inference server here that I can hit by going and typing in KF serving. I can look at how this is presented in the model UI, which I'll do in a second. Before I do that, I'm actually going to send some data. I'm going to send some predictions. I've prepared some predictions to send to both the 2 pods that I've just deployed using this code. Now I'm going to go and look at that model here. And this is bringing up the new models UI that you'll see in 1.4, right? And you have these 5 tabs across the top. You have your overview, which gives you both this predictor and transformer pod that code that I just deployed actually deployed for me. It was done by this YAML that was written for me by Kale and into KF serving a YAML that was deployed to have those 2 pods deployed. And you can see this here is giving you the spec. It's human readable, right, of the predictor pod. And you can see here, how much resources and the requests and the storage URI. There's about 120 lines of code here. So it was pretty nice that you didn't have to run all that, but you also have details available right in this detail tab on all of what my models look like. I even have performance metrics, right? So I can see my CPU utilization. I can see my memory utilization. I can see what my request by revision is doing. So this should come up here in a second, and you'll see for both the predictor pod and the transformer pod, I get these Grafana statistics that are coming out. And you see this little bump here. This is because I sent some predictions to my predictor. And the same thing for my transformer. You can see how well this is performing as well. So this is a little bit on that new models UI. What I wanted to be able to show to you today was that I was easily able to produce or serve this model just in a few commands using some metadata from my best tuned model. Now, the second use case that I want to be able to show is how to produce a Tensorboard from that metadata, from that best tuned model. So what I have is I bring in this Kale utility that allows me to create Tensorboards. This is this syntax right here that allows me to create a Tensorboard from MLMD. And then I need to be able to set an artifact to provide some metadata to set to this parameter. That artifact, again, comes from this best tuned model. From this last step here, I go to this SK learn predictor step. And again, I go into the MLMD portion. I scroll down to the bottom to the artifacts, and look what I have here. I have this SK learn Tensorboard artifact, right? That is 85, right? So I have the artifact ID. All I have to do is cut and paste that and put this into my tutorial, this 85 right here. It then applies this into this parameter, and I can create a Tensorboard just by saying Tensorboard, create Tensorboard from MLMD, give it my parameter name and a name for that. And if I go through in a few moments, I've already run this, I get a result here, and I can create a Tensorboard just by clicking on that as I did that click through. And here's the Tensorboard that was created for me. And if I double click into this, you can see I've got my prediction error from random forest regressor. I've got my best fit line, my identity, my R squared. So this is just a quick view of how metadata, I think, is going to be influencing what we do. And with that, Jimmy, that's the end, and I'll hand off to our next presenter. Again, if you'd like to try this tutorial, please feel free to go to this URL, which is the AutoML tutorial, which was published recently. You can see that here, and it gives you the walkthrough very easily to get through. That's it for me, Jimmy.